In this video, we are going to walk through the process to net profile my benchtop device. This one happens to be a Ci7860. Okay, so to start, in the software, I've already launched the NetProfiler window. I'm going to hit Create New, and my X-Rite device services is now talking to see what instruments are connected. It's detected my 7860 with this serial number, and I'm going to go ahead and say I want to select this device. Now I need to input what's the serial number of my tile set, and that serial number is printed on the box. It's actually printed on the back of each of the tiles in the tile set as well, because NetProfiler involves an instrument, its calibration media, and a set of tiles, okay, for a benchtop. So I'm going to come in here and I can type in the serial number, which is BTS. All right, and then I'm going to click the next button. This button down here is pretty much driving what we are doing, telling us when we can move forward and so forth. So you can see it's found the serial number of my NetProfiler standards, these tiles, when they expire, and now in order to proceed, I first have to identify and agree to the fact that my device and my standards are clean and the temperature is stable. Why do we ask that? Well, we don't want you to have taking these out of a cold office into a warm production environment, or a warm car into a cold or cool office, right? We need the tiles to be stable, that their temperature isn't going to change. We'll talk more about the temperature of the tiles in a bit. Same for the instrument, we want them to be stable. So yes, I can validate that's true. I also need to validate and agree that I understand that if there's a profile on this device, it's going to be removed as soon as I hit Start Profiling. Okay? So we're going to lose any profile that exists because we're creating a new one. And that's what we want to do today. So we'll go ahead and hit Start Profiling. And the first thing I get to do is something I get to do quite often, and that's calibrate. So with a benchtop, calibration starts, it says, guides me right there, calibrate using the white tile. It's got the serial number of the instrument on it. I'm going to go ahead and load that up here and hit Calibrate, and the instrument makes some little clicky noises. That's the white, or the light flashing, okay? And then I'm going to take the light trap, or the black trap as it's called. It locks in a certain way, okay? I'm going to hit Calibrate with that. Take some measurement of that. Now, just a step, a hint. Normally, I would always tell you to store your calibration media in the drawer of the instrument. Leave it out while you're doing net profiling, because you have to calibrate a number of times and you don't want to have to keep going back and forth for that. It's a little time saver. So now it wants to do multiple measurements on a gray and a deep blue tile. Those are from this set. So if I look, this tile is labeled mid-gray, okay? That's one of them. So the tiles actually have a recess on the back, okay, that where the arm of the sample arm fits into that. So I can place them in exactly the same spot. Now I'm going to click Measure, and then this is going to start measuring, and I'm going to wait. So we're going to take 32 measurements of that tile. It's counting them for us here. You can see we're at 2 of 32. And what it's going to do with that is check the short-term repeatability of the instrument on this mid-gray tile. Once we've done those 32 measurements, it'll give us a result, and then it'll tell us to do the same thing with the deep blue. And so we wait for the measurements. Great time to go get a cup of coffee. Okay, so our mid-gray tile is now measured. We've got a green check mark there, meaning that that was done successfully. So we're going to swap it out and now switch to the deep blue tile. Again, positioning it, fitting the sample arm into the recessed area on the back of the tile, putting it in place, and going ahead and click on Measure, and now it, just like the mid-gray, is going to measure 32 times. And again, why do we do these measurements? They're being done to validate, first of all, that the instrument can read repeatably and accurately. Because if we fail this, there's no point in trying to profile, because it would indicate something significantly wrong with the instrument. Maybe there's something going on internally with a light. lamp, whatever, right? Failure to do this step would indicate an issue. And so we have to validate that first. That's the reason for all of these measurements of these tiles. And we'll let that run, and when it's completed, we'll be able to move on to the next step. All right, so we have now completed the measurement of the blue tile, okay, the mid-gray and the deep blue. We've got green check marks. That means they were successful. We'll see the data about them at the end. And now we can go ahead and click the button here, the arrow to the right, to continue to the next step. And I'm going to take off the blue tile, put it back in the box. And as mentioned before, it's time to calibrate again. All right, so we put the white tile in place, click on Calibrate. We let that happen. And then we can swap and put up the black trap as we are prompted to do and hit Calibrate. All right, and now we've moved on to the next step in profiling, which is going to involve us measuring all of the tiles. But before we can do anything, we can't measure right now. You see that button is inactive because first I have to tell it the temperature of the NP standard as displayed on the thermometer in the NetProfiler box. So in the box there is a thermometer, digital thermometer. This one says 71.8 Fahrenheit. So I'm going to go ahead and enter that temperature here, 71.8. If you're working in centigrade or Celsius, you can enter it that way. The app is smart enough to understand which one you're entering, okay, based on the number you're entering. Now I can go ahead and hit the check mark that I've validated the temperature. If I made a mistake, there is an edit button here that I could go change that. All right, so now I need to measure all the tiles. Notice at the bottom it says order of measuring does not matter. So I just happen to always grab them in the order they are in the box and put them up there, but you can measure them in any order you want, right? And it will know which one you measured. So I put the first tile in there and I click measure. It's going to take a measurement of that tile and then it's going to tell me unprofiled, so there's no profile active, how far off from the white, in this case, am I in specular included and specular excluded, okay? So as we continue measuring these, let's talk about what's going on. So where do I get delta values from? What am I being compared to? We're being compared to the stored values for this tile set that came from the X-Rite factory, because when a tile set is created, it's measured with an X-Rite centroid device, okay, and the data for that tile set with its serial number is stored in the cloud. As I'm measuring now, what's happening is I'm comparing the results of my instrument to the results of the gold standard, if you will, what we call a centroid instrument, okay, to see how far away are we. And then once we've determined that for all of these tiles, we can then calculate a profile, which is a mathematical adjustment to the instrument to make it read closer to the centroid. Okay? So it's just a continuing process of measuring these various tiles. If I measure something wrong, or I happen to click measure with nothing in the port, you know, I forgot to put a tile up or something, right? It'll error out. But as long as I keep measuring my samples, we're good. I'm going to jump ahead just to show you that I can measure out of order and that it doesn't care which thing I'm measuring because it's smart enough to understand based on the measurement what color that was. So I'm not measuring orange right now. I'm measuring the deep blue. And it should jump ahead, as you see, and shows that, yep, you measured the deep blue. Okay. Whoops, I wanted to measure the orange next. So you want to treat these tiles with the utmost respect because they represent what the centroid instrument measured them at, provided they are well taken care of. No scratches, no cracks, obviously, clean, the tiles are clean and so forth. So you want to be really, really careful with them, handle them with kid gloves, as we might say, right, to make sure that they're very well maintained, because how your instrument is adjusted is going to be based on how we measure these tiles. So any variation in that measurement might cause your instrument to be misadjusted, quite honestly. Okay, we're up to the last tile that I need to measure, which is green. Once I get that one measured in, we will get a summary of that at the end, again, of how we did. And you can see it varies tile by tile how far off we are. Okay, the measure button is still active in case I want to remeasure a tile. For example, if I pulled the green out and as I was putting it back, I went, well, there's a great big fingerprint on there. I better clean that off because I touched it with my thumb while I was moving it and remeasure it. I can do that. Okay? I'm satisfied with all of my measurements, so I'm going to go ahead and hit next. And guess what we get to do? Our favorite activity, calibrate. All right, so we're going to measure the white. And we are going to measure the black trap. And our calibration was successful. Now it looks like I have to do the same thing all over. In fact, I do. Okay, including inputting the temperature. If I look at the temperature gauge, it has not changed. We'll talk about why we're measuring again in just a moment. All right, so I'm still at 71.8, and now it's time to start measuring again. So why are we measuring them a second time? Because the first time we measured them with this instrument in its native state, right? No profile applied, no change to the device, just simply measure it as it sees. After it was done measuring them all, when I hit the step to go next, it calculated a profile, a mathematical adjustment to this instrument to center it, to bring it back to aligning with the centroid device. Now, as I'm measuring these, the profile is in place. So you'll notice up here it says profiled DE. Before it was unprofiled DE. If you remember, the white was off by some small value. Now it's actually a 0 delta E, and specular included. So as I continue to go, we're going to see the delta values for each tile now with the profile applied. So this is essentially a validation step. We are validating the accuracy of the profile we calculated just to make sure that it's working as intended. The nice thing is at the end of this entire process, I will get a certificate which gives me all these values. So how do I do it? Typically as I'm measuring, I'm just looking to make sure that the values look like they're better now than they were before. Right? Makes me feel comfortable. Hey, look, that's a really good looking profile. I'm getting some nice small delta E numbers on these colors as I measure them. But ultimately, I'm going to do my real assessment, self-assessment of what I think about the profile once I'm done, where I can see all the values at the same time. And I can see the profiled versus unprofiled right next to one another. All right. By the way, as I'm profiling this, it should point out as well that every instrument model has a tolerance for profiling. Okay, there are some instruments have a wider tolerance, right? They're maybe more mid-tier kind of instruments. The high-end instruments have a tighter tolerance, and so each instrument each instrument type or model in NetProfiler has its own tolerance it's being judged against to determine if it's good or not. That tolerance is also shown on the certificate. So you'll be able to see for your instrument what was the average delta E tolerance that it had to meet in order to pass. Okay? We are on the last measurement we have to do. And wait for the blue. And look at that, every single thing starts with 0.0, which is fabulous. All right, so now we're going to hit next. And it's while we validate your profile, so the software is doing its own mathematical calculations, validating, yes, the profile is good. If we watch over here, there's a little button up there that just lit up and went green called NetProfiler. It's on the display here, it says NetProfiler. That's green, meaning I have a valid NetProfiler profile active. Okay? It's right above where it says it's green that I'm calibrated as well. Okay? That button wasn't on at all till it loaded. So the profile's been completed. We can look at the data here if we want, the summary, right? Our average delta E included unprofiled was 0.15. Profile is 0.04. So we've corrected, in essence, 0.11 average delta E with that profile. Same thing with excluded. We went from 0.23 to 0.05. Okay? So that profile now exists in the cloud, right? It's stored there, so you could get to that if you needed to. It's stored in this instrument, okay? We can view a report, which we'll go ahead and click on and show you what that looks like. So here's our NetProfiler Certificate of Performance, okay? It includes a date and time that we did the work, what calibration color standards, tile set, if you will, that we used, okay? It'll even tell us, the serial number of the instrument. So here's the repeatability. Remember the long series of measurements of the gray and the blue? Okay, we expected the gray to only have a 0.02 variation across all those measurements of that tile. We were at 0.009, so well inside the tolerance. The blue was an expected of 0.1, and we were 0.019. Again, very good. Okay, here's all of our measurements. You can see the creation temperature, all right, and the validation temperature. Those are the numbers I entered. We report them both Fahrenheit and Celsius. Okay, and here's our unprofiled and profiled for included, for excluded. Okay, we're at 0.04. The expected average, the max delta E that would pass for this instrument would be 0.16. So we're at 1/4 of that tolerance on this particular device. All right, so we've completed this. We've got this lovely big green check mark. I'm going to click home here. And this instrument is now sitting here ready to be profiled. Just to show you, I'm going to click create new so it talks to the instrument again to show you one more thing. Okay, it's going to go back and talk to this instrument and it says, hey, it's a profile is active that's got 30 days left. Why? Because a NetProfiler profile is good for 30 days. So for 30 days, this light is going to remain green. Okay, NetProfiler on the device, I'll be able to use it. When it gets, actually it's not for 30 days. When it gets close, I think maybe 5 days before it expires, the NetProfiler light turns yellow, right? It's warning us that it's going to expire. If I go to 31 days, the light will turn red because my profile will be expired. So plan your maintenance of your device, quite honestly, that on a monthly basis, every whatever, recurring monthly basis, you go out and profile the device to make sure it has a good, valid profile. Why do we need to do that? Because the environment you're in changes month by month. The instrument gets older month by month, right? There are minor differences, and so every 30 days you need to profile the instrument. As long as you've done that, you can have great confidence that this instrument will measure very, very well, right? And it will represent an X-Rite centroid device. If you got multiple devices that are all profiled, they're going to measure like one another. Thank you.